Hello folks, and welcome to Multiplying and Dividing Radicals. And so today we're going to multiply and divide radicals, but we're also going to end by simplifying our radicals. So we have to remember what we did last time when we were talking about simplifying radicals. You're going to need your note, your calculator, and a pen or pencil so that you can take some good notes. All right, let's get started. Now, the first thing we're going to do is we're going to multiply radicals. Remember why we're doing this. We need some rad Algebra 1 skills for the next chapter. So we have to remember how we're going to be multiplying radicals. So the first thing we want to talk about is, what does it mean to be a product property? Well, product means multiply. So this is one of the first properties that we're going to talk about when multiplying radicals. Basically what it says is that if you have two radicands under a square root, they're both underneath a square root, and you are multiplying them, they will multiply to make one thing underneath a radical. So we've kind of done this. What we did with simplifying is we started with this and we broke it down. Now we're going to work with the product property backwards. I'm going to give you two radicals and radicands to multiply. You're going to get it to be one radical, and then you're going to simplify it so that it looks nice and we don't get any decimal answers. All right, so let's go ahead and do some examples. We have two examples with the product property. So example number 1, and again, you're going to want to write this down. The pencil means you write it down, is that we want to multiply and simplify. So we have two radicals and radicands being multiplied. So what we can do is we can multiply the radicands 10 times 15 and get the square root of 150. Because 10 times 15 is 150. And now what we can do from this point is simplify. So the first step was using the product property, saying we can multiply them together. And now the second step is to simplify them using those perfect squares that we talked about last time. So what's a perfect square that goes into 150? Well, a perfect square that goes into 150 would be the square root of 25 times the square root of 6. The square root of 25 is 5. And then I would bring down the square root of 6. And that would be my final answer, 5 times the square root of 6. Okay, let's do another example. This one says the square root of 20 times 3 times the square root of 10. Now, the square root of 3 is not underneath a radical, so we're going to just leave it as a multiplier. But I'm going to put it out in front. I'm going to say that it's 3 times the square root of 20 times the square root of 10. Okay? And now, with that, I can take these two radicals and radicands and use the product property. So I'm going to use the product property. Oops. Okay? And I'm going to take 20 times 10, which is 200. Okay, I'm going to bring down the 3 as a multiplier. Remember, it's being multiplied. There's no adding and subtracting here because we do not see any addition signs or division signs or subtraction signs. So the operation is multiplication. Now we're going to simplify the square root of 200. So the square root of 200 would be the square root of 100 times the square root of 2. All right. And now we are going to bring down the 3 again. And now we're going to do anything else that can be simplified. So what is the square root of 100? The square root of 100 is 10. Okay, bring down the 3. 3 times 10 times the square root of 2, because it can't be broken down. So we're going to leave it as the square root of 2. And 3 times 10 is 30. So it's 30 square roots of 2. And that would be my final answer. Now, the second property that we have to know for radicals is the dividing property, which we don't call it the dividing property, we call it the quotient property. The quotient property means to divide. okay, the answer to the division problem, okay? So just like with multiplying, and we could split them up, Well, with dividing, we can also do the same thing. So we can take something that's 2 parts and make it 1, or we can take 1 part and make it 2 separate parts. Now, what we have to be careful with is that in the math world, we can't leave a square root in the bottom of a fraction. It's just a big, huge it's just socially not acceptable. It's a huge no-no. Okay, so we're not going to allow this to happen when we use the quotient property. So we're going to go ahead and talk about what would we do if we had a radical on the bottom. And what we do is called rationalize the denominator. So you're going to want to write that down, rationalize the denominator. It gets the square root out of the denominator, so it's no longer in the denominator. So in order to do that, what we have to do is multiply both the top and the bottom of this fraction by the square root of 2. So I'm going to multiply the top by the square root of 2 and the bottom by the square root of 2. 5 times the square root of 2 is 5 square roots of 2. That does not become 10 because the 5 is not underneath a radical. But because both these two are underneath the radical and a square root, we can take 2 times 2 and get the square root of 4. Now, what is the square root of 4? Well, it happens to be 2. So the answer is 5 square roots of 2 over 2. Okay, let's try that again. But this time, we're going to use the quotient property. So the first thing I'm going to have to do is I'm going to have to split this up into the square root of 2 over the square root of 15. Now that I've split it up using the quotient property, now I can rationalize my denominator. So I can multiply the top by the square root of 15 and the bottom by the square root of 15. Now, I can take this 2 times the 15 because they're both under radical signs. So 2 times 15 is the square root of 30, all over 15 times 15 is 225, and the square root of 225 is 15. So the bottom becomes 15, and the top becomes the square root of 30. Now, you should simplify this if it's possible. Are there any numbers that go into the square root of 30 that are perfect squares? So the first thing I would think of is 4. Yeah, 4 doesn't work. I try 9. 9 doesn't work. 16 doesn't work. 25 doesn't work. So no, it cannot be simplified any further. So our answer stops at the square root of 30 over 15. Okay, and we're going to do one last example. We're going to rationalize the denominator one more time. These are already split up for us, so the quotient property is already in place, which is nice. But now I have this 2 multiplier. So I got to make sure that I take that into consideration and be very careful. So I'm going to multiply the top and the bottom. Again, when we rationalize our denominator, we're always multiplying by the bottom because we don't want the radical in the bottom. So I'm going to multiply the top by the square root of 6 and the bottom by the square root of 6. The top becomes 2 square roots of 12 because 2 times 6 is 12. The bottom becomes the square root of 36. Well, we know the square root of 36 is 6. The top is 2 square roots of 12. But now 12 we can simplify. So how do we simplify it? Well, we use the product property. We figure out what 2 things are going to multiply to make the square root of 12. It would be 4 and 3. The square root of 4 is 2, and the square root of 3 is the square root of 3. So I'm going to rewrite this as 2 times 2 square roots of 3 because my square root of 12 is now 2 square roots of 3 all over 6. 2 times 2 is 4. 4 square roots of 3, that's a 3, all over 6 is what I would get. Now I can also simplify that problem. I can simplify that fraction by saying what goes into 4 that also goes into 6? 2. 2 goes into 4 2 times, and 2 goes into 6 3 times. And now my square root of 3 didn't change because it's not the same kind of number. So this would be my final answer. Okay, so I hope you're ready for Tuesday to come in and to practice it and hopefully get some help so that we can be good at rationalizing our denominators and working with radicals. So peace out.